There's something quietly breathtaking about staring into the night sky, knowing that every pinprick of light is a story waiting to be told, a mystery begging to be unraveled. But what if I told you that one of those glittering specks, a galaxy so close we can see its swirling arms from Earth, holds secrets so strange they challenge everything we think we know about the cosmos? Just 25 million light-years away, practically our neighbor in the grand scheme of the universe, lies the Pinwheel Galaxy, a place where the ordinary rules of physics seem to twist and warp. Its beauty is undeniable, a spiral of starlight so vivid it's been called the celestial fireworks display. But look closer and that's when things get weird. This isn't just another galaxy. The Pinwheel, also known as M101, is a cosmic laboratory of the unexplained, where stars vanish without a trace, where radiation pulses in patterns that make no sense, and where shadows move in ways that defy logic. Some of these phenomena might be glitches in our understanding. Others, they could be clues to something far bigger, something lurking just beyond the edge of human comprehension. And today, we're diving deep into 30 of the most head-scratching, spine-tingling mysteries this galaxy has to offer. From rogue black holes playing hide and seek to bizarre structures that shouldn't exist, each one is a reminder that the universe loves keeping secrets. What makes the Pinwheel Galaxy so special isn't just its strange phenomena, it's how close we are to unlocking them. Unlike distant galaxies where details blur into haze, this one lets us study its quirks up close, almost like flipping through the pages of a cosmic detective novel. Every observation peels back another layer, revealing questions we didn't even know to ask. So consider this your invitation, a front row seat to the greatest unsolved cases in our cosmic backyard. By the end, you won't just see the pinwheel as another pretty spiral in the sky. You'll see it as a living, breathing puzzle, one that might just redefine our place in the universe. Ready to unravel the impossible? Let's begin. At the heart of the Pinwheel Galaxy, something is very wrong with the rules. Most supermassive black holes behave like cosmic lighthouses. Their jets of energy shoot out in predictable, symmetrical beams aligned with their rotation. But the one anchoring M101, it's spewing chaos. Imagine a fire hose flailing wildly instead of aiming straight, and you'll start to grasp the strangeness here. These jets twist, flicker, and even split apart in ways that shouldn't be possible. It's as if the black hole itself is drunk on power, defying the neat equations astronomers rely on. So what's causing this cosmic tantrum? One leading theory suggests the black hole might be feasting too fast. Normally, matter spirals inward in an orderly disk, but here, it could be gorging on gas and stars in violent, messy bursts. That kind of feeding frenzy would destabilize the jets, sending them wobbling like a spinning top about to fall. Others speculate something even wilder, that the black hole's axis is physically tilting over time, perhaps from a past collision with another black hole. Picture a merry-go-round slowly tipping sideways while still spinning, its poles no longer pointing where they should. But the real shocker, these misaligned jets might be more than just a quirk. They could rewrite the textbook on how black holes influence their galaxies. Normally, jets regulate star formation, heating up gas so it can't collapse into new stars. But erratic jets like these might create pockets of unpredictable turbulence, sparking strange bursts of stellar birth where there should be silence. It's a reminder that even the most monstrous objects in the universe can have a delicate, unbalanced side, one we're only beginning to understand. And here's the unsettling part. If our models can't explain what's happening in the pinwheel's core, how many other black holes out there are secretly breaking the rules too? Now, let's turn our attention to a cosmic vanishing act that left scientists scratching their heads. In the Pinwheel Galaxy, there once existed a colossal star cluster, a glittering congregation of hundreds of thousands of stars, all bound together by gravity. Astronomers had observed it for years, cataloging its brightness, its structure, until one day, it simply wasn't there anymore. No explosion, no lingering debris, no telltale signs of collapse. It was as if someone had flipped a switch and erased it from existence. What could make an entire star cluster disappear? One possibility is dark matter, the invisible glue that holds galaxies together. Some theorists suggest a dense knot of dark matter may have drifted through the cluster, its gravitational pull so intense it tore the stars apart, scattering them into the void before moving on like a silent cosmic wrecking ball. The frightening part, we wouldn't even see it happen. Dark matter doesn't emit light or interact with ordinary matter in any way we can directly detect. It could shred a star cluster without leaving a single fingerprint behind. Then there's the more speculative but undeniably thrilling hypothesis. Could this be the work of a civilization far beyond our own? Imagine a species so advanced they've mastered stellar engineering, dismantling entire clusters to harness their energy or build structures we can't even conceive of. While the idea sounds like science fiction, it's not entirely outside the realm of possibility. After all, nature doesn't typically erase things so cleanly. If a black hole or collision were responsible, we'd expect remnants, some trace of violence. But this was surgical. The unsettling truth is we may never know for certain. The Pinwheel Galaxy keeps its secrets well, but the mystery forces us to confront how little we truly understand about the universe's darker corners and the silent forces, natural or otherwise, that might be shaping them right under our noses. Among the Pinwheel Galaxy's sweeping spiral arms, there's one that doesn't play by the rules, a faint, ghostly structure that flickers in and out of existence like a cosmic mirage. Astronomers first noticed it as a wispy trail of stars and gas, barely visible in some telescope observations but completely absent in others. It's as if the galaxy itself is teasing us, unveiling a secret arm one moment and snatching it back the next. What could cause a spiral arm to behave so erratically? The leading suspect is gravity specifically, the gravitational pull of unseen matter warping the galaxy's structure. Just as a boulder hidden beneath a river's surface distorts the flow of water, dense pockets of dark matter could be bending the pinwheel's stellar fabric, creating temporary ripples that manifest as this phantom limb. These gravitational hiccups might even tug stars and gas out of their usual orbits, weaving them into fleeting patterns before scattering them back into the void. But there's another, even stranger possibility. This ghostly arm might not be part of the pinwheel at all. Some researchers suggest it could be the shredded remains of a smaller galaxy, one that strayed too close and was torn apart by tidal forces. Like smoke lingering after a fire, the debris could be drifting in and out of view as it slowly merges with its larger neighbor. If true, it would mean we're witnessing the aftermath of a cosmic crime scene, a galaxy devoured, its final traces fading like footsteps in the sand. The most unnerving part, this phenomenon forces us to question how much of what we think we see in the universe is real, and how much is just a trick of the light, shadows cast by forces we're only beginning to detect. After all, if an entire spiral arm can vanish before our eyes, what else might be hiding in plain sight? Deep within the Pinwheel Galaxy's vibrant spiral arms, there's a patch of space that shouldn't exist, a region so quiet it sends chills down astronomers' spines. While the rest of the galaxy crackles with the radio chatter of pulsars, supernova remnants, and swirling gas, this zone is eerily mute. No bursts, no hums, not even the faintest whisper of electromagnetic static. It's as if someone pressed pause on the universe's background noise, creating a perfect bubble of radio silence. Natural explanations for this void range from the mundane to the mind-bending. One possibility involves an unusually dense cloud of cold hydrogen gas absorbing radio waves before they can reach our telescope, like a cosmic sponge soaking up sound. But here's the catch, even the thickest gas clouds usually let some frequencies slip through. This silence is absolute. Another theory points to a recent collision between massive stellar objects like neutron stars, whose aftermath might have temporarily swept the area clean of radio emissions. Yet these events typically leave behind telltale debris or gravitational ripples, and this zone shows no such scars. Then there's the more unsettling prospect. What if the silence isn't natural at all? Imagine a civilization advanced enough to cloak its presence by bending electromagnetic waves around its territory, creating a perfect dead zone. On Earth, stealth technology aims to make aircraft invisible to radar. An alien society might scale this up to planetary or even interstellar levels, rendering entire star systems undetectable. Or consider the darker alternative, a predatory species deliberately silencing regions to ambush unwary travelers, like a spider waiting in the center of an invisible web. But the most profound implication of this radio silence is simpler and humbling. It forces us to confront how much we still rely on sound to map the cosmos. If an entire sector of space can hide in plain auditory darkness, what other mysteries might we be missing simply because we're listening for the wrong things? The Pinwheel Galaxy's quiet corner isn't just a puzzle, it's a mirror reflecting the limits of our own perception. And if nature alone can't explain this void, we're left with a question that lingers long after the data fades to static. Is silence just an absence of noise, or could it be a signal in itself? Among the Pinwheel Galaxy's countless worlds, there's one that gleams like a jewel in the cosmic dark, a planet so dense, so impossibly radiant, it might as well be carved from pure diamond. Orbiting a dead star called a pulsar, this world defies everything we know about planetary formation. Picture a sphere where the very ground beneath your feet, if you could stand on it, wouldn't be rock or ice, but crystalline carbon compressed into perfection by forces beyond human comprehension. This isn't just poetic speculation. The conditions here are extreme enough to turn fantasy into reality. The pulsar it orbits is a stellar corpse, spinning so fast its gravity would crush a normal planet into dust. But this world, it's built to withstand the pressure. Scientists believe its core is made of crystallized carbon, forged under temperatures reaching thousands of degrees and pressures millions of times greater than Earth's atmosphere. Think of coal squeezed in a cosmic vise until it transforms into something flawless, a diamond the size of a planet. Yet the real wonder isn't just what it's made of, but how it got there. Most planets form from the leftover gas and dust swirling around young stars, but this one likely has a far more violent origin story. One theory suggests it was once part of a massive star, stripped down to its carbon-rich core when its companion exploded in a supernova. The blast would have vaporized everything volatile, leaving behind a skeletal core of compressed carbon, polished by the relentless heat and radiation of its pulsar host. Over eons, that carbon could have recrystallized, turning the entire world into a celestial gemstone. But here's the twist: a diamond planet shouldn't exist this close to a pulsar. The radiation and gravitational tides should have torn it apart or vaporized it long ago. The fact that it's still here, still shining, means there's something we're missing, some hidden physics that allows such fragile beauty to survive in the universe's most brutal environments. And that raises an even bigger question. If this glittering anomaly exists, what other impossible worlds might be waiting in the pinwheel's depths? The universe, it seems, has a flair for turning the unimaginable into the undeniable. Some cosmic explosions follow the rules they burst to life in stellar nurseries, where young, massive stars live fast and die young, but not this one. In the outskirts of the Pinwheel Galaxy, a supernova erupted where no star should have been, lighting up a cosmic dead zone with the fury of a dying sun. It's the equivalent of finding a lit firework sitting alone in a desert, no launcher, no ignition source, just raw, inexplicable destruction where nothing was supposed to happen. Astronomers first spotted this rogue explosion as a sudden flare in an otherwise quiet region, far from the galaxy's bustling spiral arms. Supernovas typically announce their arrival with decades of warning. Their parent stars swell and tremble before the final collapse. But this star, it left no paper trail. One moment the area was dark, the next it was outshining entire star clusters. The question isn't just how it exploded, it's how it got there in the first place. One theory suggests the star was a cosmic fugitive, violently ejected from its birthplace by gravitational chaos. Picture a stellar game of pinball. A close encounter with a black hole or a dance too tight with a binary partner could have flung it across the galaxy at breakneck speeds, sending it careening into the void until it finally detonated in solitude. If true, the star might have traveled for millions of years before its dramatic end, a vagabond meeting its fate far from home. But there's a twist. Some researchers argue this supernova might not have been a solitary act. It could have had an invisible accomplice. Dark matter, the elusive substance that outweighs visible matter 5 to 1, might have played a role. If dense knots of dark matter clustered in this empty region, their gravitational pull could have compressed stray gas just enough to ignite a star in isolation, one that burned bright and fast before vanishing in a blaze of defiance. It's a controversial idea, but if proven, it would mean dark matter isn't just a passive scaffold. It could actively shape stellar destinies. Then there's the unsettling third option. What if the star didn't explode on its own at all? Could something or someone have triggered it? While it sounds like science fiction, advanced civilizations theoretically capable of engineering stellar deaths are not beyond the realm of possibility. Maybe the supernova was a signal, a weapon, or even an accident. Nature rarely leaves such clean mysteries in its wake. The rogue supernova forces us to confront how little we know about the lives and deaths of stars. If a sun can explode in the cosmic equivalent of a ghost town, what other rules might we be missing? The Pinwheel Galaxy, it seems, excels at turning textbook assumptions into confetti. Nestled between the Pinwheel Galaxy's spiraling arms, there's a cosmic anomaly that plays tricks with light itself, the Mirror Nebula. Unlike most nebulae, which scatter and diffuse starlight into hazy clouds of color, this one reflects light with an almost unnatural precision. Gaze into its depths and you're met with a near-perfect symmetrical glow, as if the universe itself polished a giant pane of celestial glass and hung it amidst the stars. What makes this nebula behave like a mirror? The secret lies in the alignment of its dust grains. Most cosmic dust tumbles chaotically, scattering light in random directions. But here, something has combed these particles into eerie uniformity. Their flat surfaces all facing the same direction like billions of microscopic mirrors angled just right. When starlight hits them, instead of bouncing wildly, it reflects in unison, creating that startling symmetry. Scientists suspect magnetic fields are the invisible sculptors behind this phenomenon. The Pinwheel Galaxy's magnetic environment is unusually strong and orderly in this region, possibly due to shock waves from nearby supernova or the gravitational pull of hidden structures. These forces could act like cosmic fingers, gently aligning each dust grain until they collectively behave as one vast reflective surface. But there's another layer to this mystery. For the Mirror Nebula to maintain such perfect alignment, the surrounding environment must be incredibly stable. No stellar winds, no turbulence, nothing to disrupt the delicate choreography of those dust particles. Yet space is rarely this calm. It's almost as if the nebula exists in a pocket of unnatural stillness, shielded from the chaos that defines the rest of the galaxy. Then there's the question of scale. Small mirrored patches exist elsewhere in the universe, but nothing matches the Mirror Nebula's vast, unbroken symmetry. Some researchers wonder if we're witnessing something transitional, a nebula caught in a fleeting moment of perfect alignment before cosmic currents inevitably tear it apart. Others propose it might be recycling starlight in a way we've never seen, potentially concentrating energy into beams or patterns we don't yet recognize. The most haunting possibility, this could be a signpost for something far stranger. Advanced civilizations, should they exist, might deliberately engineer such structures to harness or redirect light for purposes beyond our understanding. While there's no evidence to support this, the unnerving perfection of the Mirror Nebula forces us to confront how little we know about the potential for order in the cosmos. So the next time you look at a mirror, remember, the universe might be gazing back, its reflections hiding secrets we've only begun to decode. And in the Pinwheel Galaxy, one of those secrets shines with impossible precision, waiting for us to ask the right questions. There's a quasar in the Pinwheel Galaxy that doesn't just shine, it stutters. Like a cosmic film reel skipping frames, its light arrives at our telescopes in hiccups and delays, defying the steady rhythm we expect from these brilliant beacons. Most quasars pulse with reliable regularity, their emissions governed by the predictable physics of supermassive black holes feeding on gas, but this one, it flickers with no discernible pattern, its light stretched and compressed as if passing through invisible funnels in space itself. Einstein's theory of general relativity predicted this kind of space-time trickery. Massive objects warp the fabric of the universe around them, slowing time and bending light like a lens. Normally, these distortions are subtle, but here, something has amplified the effect to extremes. One explanation points to a previously unseen cosmic structure between us and the quasar, perhaps a hidden cluster of dark matter so dense it acts as a natural magnifying glass, twisting the quasar's light along multiple paths. Picture a flashlight beam passing through a room full of mirrors. Some photons take direct routes while others bounce wildly, arriving seconds or even years later. The more tantalizing possibility involves wormholes, theoretical tunnels through space-time. While no definitive evidence exists, some models suggest a microscopic wormhole near the quasar could be shredding its light beam, spitting fragments out at different times. Imagine shouting into a pipe with multiple exits. Your voice would reach listeners at varying intervals. If true, this quasar might be our first glimpse of nature's subway system, shortcuts through the universe's back alleys. But the strangest detail, the delays aren't random. Hidden in the data are faint mathematical patterns like echoes of a deeper structure. Some researchers argue this could hint at space-time itself vibrating, much like a drumhead quivering after being struck. These cosmic harmonics might mean we're detecting the universe's fundamental geometry resonating, a hum so quiet we'd never notice without anomalies like this quasar to amplify it. What began as a curiosity now challenges our perception of time's flow. If light can be stretched and folded so dramatically in one corner of the Pinwheel Galaxy, how many other cosmic clocks might be ticking out of sync? The universe, it seems, doesn't just bend space, it plays with time like a child splashing in a puddle, scattering ripples we're only starting to trace. There's a gas cloud in the Pinwheel Galaxy that's doing the cosmic equivalent of swimming upstream, moving boldly against the flow of the entire galaxy's rotation. Picture a salmon leaping up a waterfall, except this isn't some determined fish. It's an entire structure of interstellar gas, massive enough to cradle newborn stars, yet somehow defying the gravitational pull that keeps billions of other objects in orderly orbits. Most clouds drift lazily along with their galaxy's spin, like leaves caught in a slow-moving river. But this one, it's sprinting in the opposite direction, and that defiance has astronomers scrambling for answers. The first clue lies in speed. This rogue cloud isn't just meandering against the tide, it's racing at hundreds of kilometers per second, fast enough to escape the galaxy's grasp if it kept up the pace. Normally, such velocity would suggest a recent collision or explosion nearby, something violent enough to give the cloud a cosmic shove. Yet scans reveal no trace of a triggering event, no supernova remnants, no black hole outbursts, not even the gravitational wake of a passing star cluster. It's as if this cloud suddenly decided to rebel against the universe's rules with no explanation for where it found the energy. That's where dark matter enters the story. Some theorists propose that an invisible knot of dark matter, drifting through the galaxy like a phantom iceberg, could be tugging the cloud off course. Though dark matter doesn't interact with light, its gravitational influence is undeniable, and if a dense clump passed close enough, it might have yanked the cloud onto this strange new path. Think of it like a stealthy comet, invisible but for the disturbance it leaves behind. Yet even this theory has holes. Dark matter typically disperses in diffuse halos around galaxies, not compact enough to redirect something so massive so abruptly. Then there's magnetism. The Pinwheel Galaxy is threaded with powerful magnetic fields far stronger than our Milky Ways. These fields are usually too weak to move entire gas clouds, but under the right conditions, they might act like cosmic conveyor belts, channeling charged particles along invisible rails. If this cloud is rich in ionized gas, those magnetic forces could be slingshotting it against the galactic current. It's a tantalizing idea, though no known magnetic field should be strong enough to produce this level of defiance. But here's the twist that really bends the mind. What if the cloud isn't moving at all? Alternative models suggest we might be witnessing an illusion, a warp in spacetime itself creating the appearance of backward motion. Large concentrations of mass, like hidden black holes or dark matter filaments, could bend light in ways that make stationary objects seem to race in impossible directions. It's the universe's version of a hall of mirrors where nothing is quite where or how it appears. The most humbling part, this gas cloud isn't just a curiosity. Its behavior could rewrite our understanding of how galaxies evolve. If forces we can't yet measure can fling entire structures against a galaxy's spin, what else might they be capable of? Every rogue motion, every cosmic outlier forces us to question whether we're seeing the full picture or just the fragments the universe chooses to reveal. And in the Pinwheel Galaxy, those fragments keep pointing toward mysteries we've only begun to name. The Pinwheel Galaxy holds a mystery that pulses across the cosmos like a heartbeat, a fast radio burst, or FRB, that refuses to play by the rules. Unlike most of these explosive cosmic signals, which flash once and vanish without warning, this one repeats with eerie precision. Every 132 days, like clockwork, a surge of radio waves erupts from the depths of M101, blasting through space with enough energy to outshine entire galaxies for milliseconds. It's as if the universe itself tapped out a coded message, daring us to decipher it. What could produce such a perfectly timed signal? The leading suspect is a highly magnetized neutron star known as a magnetar. These celestial powerhouses spin at dizzying speeds, their intense magnetic fields twisting and snapping like rubber bands stretched to the breaking point. When those fields finally recoil, they can unleash bursts of radiation so powerful they're detectable across billions of light years. But even among magnetars, this one's behavior is bizarre. Most neutron stars pulse with chaotic irregularity, their bursts as unpredictable as lightning. This one's rhythmic cadence suggests something far more deliberate, almost mechanical in its precision. Some astronomers speculate the magnetar might be trapped in a cosmic dance with another massive object, perhaps a black hole or a dense companion star. Their gravitational tug-of-war could be winding the magnetar's magnetic springs tighter at regular intervals, like a clockwork toy being rewound. Each time the tension reaches critical mass, boom. Another burst. If true, this would mark the first time we've witnessed such a finely tuned celestial mechanism, where gravity and magnetism collaborate to create a signal as reliable as a metronome. Then there's the theory that makes everyone lean in a little closer. Could this be something more than natural? FRBs have long fueled speculation about extraterrestrial origins, and the Pinwheel's repeating burst only deepens the intrigue. Imagine a civilization advanced enough to harness the energy of a neutron star, using its power to beam messages or warnings across the cosmos. The timing is too perfect, the signal too clean to dismiss outright. Nature rarely serves up patterns this precise without a hidden hand guiding them. But here's the twist that keeps scientists up at night. Recent observations suggest the bursts aren't just repeating, they're evolving. The intervals between them have begun shifting by fractions of a second, as if whatever's producing them is slowly winding down or gearing up for something bigger. It's a subtle change, but in the ultra-precise world of astrophysics, even microseconds matter. Could this be the natural decay of a dying magnetar, or the deliberate adjustment of something far more intelligent? One thing's certain, every time that burst echoes across the void, it carries two messages, one written in the language of physics, the other in the silent thrill of the unknown. And in the Pinwheel Galaxy, that duality isn't just a mystery, it's an invitation. Deep within the Pinwheel Galaxy's sprawling disk, scientists have stumbled upon a cosmic checkpoint, a boundary where high-energy particles simply refuse to go any further. Cosmic rays, those hypercharged fragments of atoms racing through space at near light speed, slam into this invisible wall like moths hitting a window pane. Beyond it, silence. No matter how powerful the particle, how relentless its momentum, something in this region strips it down to nothing. It's as if the galaxy built its own force field, and we have no idea who or what flipped the switch. The most plausible explanation involves magnetic fields twisted into something far stranger than usual. Normally, magnetic fields bend cosmic rays gently, like a breeze nudging a sailboat off course. But here, simulations suggest the fields might be tangled into knots so tight they act like particle shredders, unraveling incoming rays before they can penetrate deeper. Picture a cosmic version of those industrial shredders that rip entire cars into scrap, only instead of metal, it's dismantling atoms themselves, the terrifying part. Fields this intense shouldn't form naturally. They'd require energy equivalent to 1,000 supernovae concentrated into a single patch of space, a phenomenon with no known astrophysical blueprint. Then there's the exotic matter hypothesis. Some quantum theories predict particles we've never detected, exotic cousins to protons and electrons with bizarre properties. If these particles clustered here, they might interact with cosmic rays in ways that erase them from existence entirely. Think of it like throwing a stone into a pond, only instead of ripples, the water instantly turns to fog. These interactions wouldn't leave debris or radiation, they'd just silence. While purely speculative, the idea gains traction because normal physics can't explain the abruptness of this barrier. Nature rarely draws lines this sharp without something extraordinary lurking beneath, but the most provocative theory, this might not be a natural structure at all. Advanced civilizations, if they exist, could theoretically build cosmic ray shields to protect delicate systems or mark territory. On Earth, we already use magnetic fields to deflect solar radiation from spacecraft. Scale that up to galactic proportions, and you get something eerily similar to the Pinwheel's invisible wall. It's a wild notion, but the absence of any conventional explanation keeps it lingering in the scientific conversation. After all, if the universe has taught us anything, it's that the line between impossible and inevitable is thinner than we think. What makes this barrier truly humbling isn't just its existence, it's the reminder of how much we still don't understand about the forces stitching reality together. If a single region of one galaxy can halt particles that barrel through the rest of the universe unimpeded, what other rules might be waiting to be rewritten? The Pinwheel Galaxy doesn't just hide its secrets, it guards them, and this invisible wall might be the most defiant sentry of all. Most stars get one grand finale, a single, spectacular supernova that marks the end of their cosmic story. But in the Pinwheel Galaxy, astronomers have found a stellar rebel that refuses to stay dead. Meet the zombie star, a cosmic anomaly that's exploded not once, but multiple times, clawing its way back from oblivion, each time like something out of a celestial horror show. How does a star cheat death so brazenly? The answer might lie in a forbidden dance with another star. Picture two massive stars locked in a gravitational embrace, spiraling closer over millennia until their outer layers collide and merge. This violent tango could dump fresh fuel onto one of the stars, reigniting its furnace long after it should have burned out. Every time it nears death, its partner's stolen matter gives it new life until the next explosion tears them apart again. It's stellar vampirism on a cosmic scale, with one star feeding off another to defy the natural order. Then there's the exotic matter theory. Under normal conditions, supernova obliterate stars so thoroughly that only a black hole or neutron star remain. But some models suggest that under extreme pressures, a star's core might transform into strange quark matter, a bizarre, ultra-dense state where protons and neutrons dissolve into a soup of fundamental particles. This exotic core could act like an indestructible anchor, allowing the star to rebuild itself after each cataclysm. Imagine a phoenix whose ashes are laced with something unbreakable, ensuring it always rises anew. Yet the zombie star's most unsettling feature isn't its resilience, it's the light it emits. After each explosion, it doesn't just return to normal, it burns hotter and brighter, as if each death sharpens its intensity. Spectrographs reveal elements in its atmosphere that shouldn't survive supernova at all, like cosmic fingerprints of the impossible. Some researchers argue this points to layers of the star being peeled back like an onion, revealing deeper, stranger chemistry with every rebirth. Others whisper about Thorne-Zitkow objects, hypothetical hybrid stars with neutron hearts cloaked in gaseous envelopes, stellar chimeras that blur the line between star and remnant. But here's the chilling twist. If stars can resurrect themselves, how many others might be lurking in the cosmos, masquerading as ordinary suns while hiding violent pasts? The zombie star forces us to question whether death in the universe is ever truly final or just another doorway to something we don't yet understand. And in the Pinwheel Galaxy, that doorway might be wider than we ever dared to guess. Tucked away in the faint outskirts of the Pinwheel Galaxy, there's a glow so delicate it's almost ghostly, thin, thread-like filaments of light stretching across the void like cosmic spider silk. These aren't just remnants of stellar explosions or gas clouds, they're potential fingerprints of something far stranger, cosmic strings, theoretical cracks in the fabric of spacetime itself. If they're real, these strings could be relics from the universe's birth, frozen flaws in creation's blueprint that never smoothed out. The idea of cosmic strings comes straight from the edges of theoretical physics. Picture the early universe as a cooling vat of molten glass. As it solidified, tiny fractures might have formed imperfections where the fabric of reality didn't stitch together perfectly. These fractures would be unimaginably dense, thinner than a proton, but with the mass of entire mountain ranges packed into every inch. Their gravitational pull would warp space around them, bending light and time in ways that leave behind these eerie, glowing trails. What makes the pinwheel's filaments so compelling is their uncanny resemblance to what strings should look like. Unlike nebulae or star clusters, these structures don't dissipate or blur at their edges. They're razor sharp, as if someone took a knife to spacetime and left the cuts exposed. Some even exhibit tiny, periodic kinks, exactly the kind of wiggles predicted when strings interact or snap under their own unimaginable tension. It's like finding a fossil with the perfect imprint of a creature science only ever dreamed existed. But cosmic strings aren't just cosmic curiosities, they could be the missing link to understanding the universe's structure. String theory, the controversial theory of everything, suggests that all particles and forces are vibrations of tiny, multidimensional strings. If macroscopic versions of these strings exist, like the ones potentially glowing in the pinwheel, they'd be a bridge between the quantum world and the cosmos we see. Imagine stumbling upon a single thread that, when pulled, unravels the knots between gravity and quantum mechanics. That's the scale of what's at stake. Yet the most electrifying possibility lies in what these strings could do. According to some models, cosmic strings might vibrate with the energy of the Big Bang itself, humming frequencies so pure they could warp time or even create closed loops capable of time travel. Others speculate that colliding strings could trigger spontaneous bursts of new universes like soap bubbles pinching off from a larger film. If the pinwheel's filaments are truly strings, we might be looking at the universe's seams, places where reality is stitched together just loosely enough to glimpse what lies beyond. Of course, skepticism lingers. Some astronomers argue these filaments could be shock waves from ancient galactic collisions or magnetic vortices twisted into unusual shapes. But here's the catch. None of those explanations account for the filaments' unnatural straightness or their eerie resistance to dissipation. Nature prefers curves and chaos. These structures are geometry incarnate, as if they were drawn with a ruler across the cosmos. Whether cosmic strings or something even stranger, these glowing threads challenge us to rethink reality's scaffolding. And if they are the real deal, the Pinwheel Galaxy isn't just showing us a mystery, it's offering a backstage pass to the universe's deepest workings. One thing's certain, the closer we look, the more the cosmos feels less like a machine and more like a tapestry, woven with threads we're only beginning to see. Astronomers studying the Pinwheel Galaxy thought they'd struck gold when they spotted the first evidence of an exomoon, a moon orbiting a planet beyond our solar system. The telltale signature was unmistakable. Rhythmic dips in starlight as both the planet and its unseen companion passed in front of their host star. For months, the data held steady, painting a picture of a stable system with a Jupiter-sized planet and a Neptune-scale moon locked in a gravitational embrace. Then, just as researchers prepared to announce the discovery, the moon's signal vanished without a trace. No gradual fade, no telltale debris, just silence where there should have been celestial choreography. The immediate assumption was human error. Exomoons are notoriously difficult to detect. Even the faintest interference, a passing cosmic ray, a hiccup in telescope calibration, can mimic or erase their signals. Teams reanalyzed the data, cross-checking instruments and methodologies, but the moon refused to reappear. It wasn't just hiding, it was as if it had never existed at all. That's when a more unsettling possibility emerged. What if the moon had been real, but something or someone had destroyed it? Natural explanations range from the violent to the bizarre. Exomoons orbiting too close to their host planets can be torn apart by tidal forces, shredded into rings or scattered into space. But this moon's predicted orbit was stable, far enough from its planet to avoid such a fate. Another theory suggests a catastrophic collision, perhaps with a rogue planet or a dense asteroid swarm, shattering the moon into dust too fine to detect. There's precedent for this in our own solar system. Uranus's tilted axis hints at a planet-scale impact early in its history. Yet even these scenarios struggle to explain the absence of debris. A shattered moon should leave a trail, a haze of particles reflecting light or absorbing specific wavelengths. Instead, the observations showed only pristine emptiness. Then there's the more speculative angle. Could the moon have been artificial? While it sounds like science fiction, advanced civilizations might build megastructures around planets to harvest energy or serve as habitats. If such a structure collapsed or was dismantled, it could vanish from our telescopes as abruptly as this exomoon did. The idea isn't as far-fetched as it seems. Astronomers already scan for unusual light patterns that could indicate artificial constructs. But without concrete evidence, it remains a tantalizing what-if at the edge of credible science. The most compelling and humbling explanation ties back to the challenges of observing distant worlds. Light from the Pinwheel Galaxy takes 25 million years to reach us, meaning we're seeing the system as it existed in the deep past. In that time, the planet's orbit might have shifted, dragging its moon into a new position that no longer transits the star from our vantage point. Alternatively, stellar activity flares or sunspots could have temporarily masked the moon's signal, creating the illusion of a disappearance. It's a reminder that the universe rarely serves up its secrets cleanly. Even the most tantalizing data can be a hall of mirrors. For now, the phantom exomoon remains one of the Pinwheel's most frustrating enigmas. Whether it was a glitch, a cataclysm, or something beyond our current understanding, its fleeting presence forces us to confront how little we know about the intricate dances of distant worlds. And if moons can vanish without a trace, what other marvels might be flickering in and out of view, just beyond the edge of our detection? Among the Pinwheel Galaxy's billions of stars, one stands out not for its brilliance but for its sheer audacity. This stellar rebel races through space at nearly 3,000 kilometers per second, fast enough to cross the entire United States in the blink of an eye. While most stars orbit their galaxies in orderly, predictable paths, this one is fleeing the pinwheel's spiral arms like a cosmic fugitive, leaving a trail of shocked gas and unanswered questions in its wake. How does a star reach such impossible speeds? The leading theory points to a gravitational slingshot from the galaxy's central black hole. Picture this: two stars locked in a binary dance wander too close to the monster lurking in the pinwheel's heart. In a flash of violence, the black hole's tidal forces rip one star apart while flinging its companion outward at speeds that defy logic. It's the ultimate cosmic heist, stealing momentum from a black hole itself. Simulations show these encounters can accelerate stars to velocities that would make even light pause in disbelief. But there's another contender in this celestial speed contest: supernova kicks. When massive stars explode, asymmetrical detonations can launch surviving remnants like shrapnel from a grenade. If this runaway was once part of a binary system where its partner detonated catastrophically, the blast could have sent it careening across the galaxy, a stellar orphan cast adrift by its siblings' dying breath. The telltale signs: a lack of heavy elements in its wake, suggesting it wasn't torn from a chaotic galactic core, but instead blasted clean by a supernova's fury. Here's where it gets stranger. This star isn't just moving fast, it's accelerating. Most hypervelocity stars slow over time as they plow through interstellar gas, like a bullet losing speed in water. But this one's trajectory suggests something still pushing it, as if invisible hands keep giving it cosmic shoves. Some researchers speculate it might be surfing shockwaves from overlapping supernova remnants, each explosion's aftermath acting like a booster rocket. Others wonder if we're seeing the influence of dark matter currents, invisible rivers in space that tug on stars in ways we can't yet map. And then there's the outlier possibility. What if this star didn't originate in the pinwheel at all? Hypervelocity stars can theoretically be intergalactic hitchhikers, flung from neighboring galaxies during close encounters billions of years ago. If true, this traveler might carry chemical signatures alien to the pinwheel's stellar population, a rogue fingerprint from another corner of the universe entirely. What makes this runaway so captivating isn't just its speed, it's the lingering question of where it's headed. Most escapees are doomed to fade into the freezing void between galaxies, but this one's trajectory hints at a slim chance of interception. In roughly 20 million years, it might pass close enough to another galaxy to be captured, trading one spiral arm for another. Until then, it serves as a reminder that even in a universe bound by gravity's rules, there's always room for a rebel, and the Pinwheel Galaxy just launched its fastest. There's a storm raging through the Pinwheel Galaxy, but you'd never know it just by looking. Unlike the swirling arms of gas and starlight that define its beauty, this tempest is invisible, detectable only by the way it warps the fabric of reality itself. Astronomers call it the dark matter hurricane, a vast, fast-moving river of unseen particles tearing through space at nearly 500 kilometers per second, leaving ghostly fingerprints in its wake. How do you track something you can't see? Gravity holds the clues. As this dark matter stream plows through the galaxy, its immense mass bends light from background stars like a cosmic funhouse mirror, a phenomenon called gravitational lensing. By mapping these subtle distortions, scientists have pieced together the hurricane's path. revealing a structure so immense it could span the distance between Earth and the Pinwheel Galaxy twice over. The sheer scale of it defies intuition, an invisible tsunami, tall enough to swallow solar systems whole, yet utterly silent as it passes. So where did this phantom tempest come from? The leading theory points to a galactic crime seen billions of years in the making. When smaller galaxies collide with larger ones, their stars and gas often merge seamlessly, but their dark matter halos. Those can splinter into long, filamentary streams like cosmic paint streaked across a canvas. The Pinwheel's hurricane might be the debris of a dwarf galaxy torn apart by gravitational tides, its dark matter scattered into this eerie, linear gale. It's a relic of the universe's violent adolescence, a fossilized whisper of the chaos that shaped the cosmos. But here's what makes this storm truly unsettling. It's not just passing through, it's interacting. Most dark matter is thought to drift harmlessly through ordinary matter, barely leaving a trace. Yet delicate measurements suggest this stream's gravitational tug might be subtly perturbing star clusters and gas clouds in its path, like an invisible hand brushing through tall grass. If confirmed, it would mean dark matter isn't just a passive scaffold holding galaxies together. It could actively sculpt them, its invisible currents rearranging the visible universe in ways we're only beginning to sense. Then there's the tantalizing possibility that this hurricane could be our best shot at catching dark matter. Particle detectors on Earth have spent decades hunting for hypothetical dark matter particles with no definitive success. But a concentrated stream like this, it's like turning a scattered shower into a fire hose, increasing the odds of a direct hit. Some models even suggest the particles here might be different from the rest of the galaxy's dark matter, carrying unique signatures from their cataclysmic origins. If we're lucky, this invisible storm could rain answers at last. Yet the most humbling revelation isn't about dark matter. It's about us. The Pinwheel's hurricane reminds us that the universe is far richer, far stranger than what our eyes perceive. Right now, as you hear these words, an unfathomable tide of something is surging through the cosmos, bending light, twisting space-time, and rewriting the rules of reality. And we'd never know it existed if not for the quiet, persistent language of gravity. The storm isn't the anomaly, our blindness to it is. And somewhere in that darkness, the universe is still whispering secrets we've only just begun to hear. At the edge of the Pinwheel Galaxy, two cosmic heavyweights are locked in a dance so slow it defies physics. A pair of supermassive black holes waltzing around each other at a pace that would make glaciers seem impatient. Most binary black holes spiral toward collision over millions of years, their orbits tightening as gravitational waves bleed energy away. But this duo, they're circling each other once every 5 centuries, a leisurely rhythm that has astronomers scrambling to rewrite the rules of orbital mechanics. What makes these black holes move like they're stuck in cosmic molasses? The first clue lies in their separation nearly 1/10 of a light year apart, a distance so vast it should take unimaginable forces to stabilize their sluggish orbit. Normally, black holes this massive would either collide quickly or fling each other apart, yet here they hover in perfect equilibrium, as if suspended by invisible threads. Some theorists point to gravitational wave anomalies. Perhaps the fabric of spacetime itself behaves differently in this region, dampening the energy loss that typically drives black holes together. Imagine two magnets repelling each other not through magnetism, but because the very air between them thickens to molasses. Then there's the wild card, an unseen third object tugging at the system. Just as the moon stabilizes Earth's tilt, a hidden intermediary may be another black hole, a dense dark matter clump, or even a primordial wormhole, could be acting as a gravitational anchor, keeping the pair in this bizarre slow-motion embrace. Simulations show such three-body systems can produce orbits that linger for eons before finally collapsing, like a pendulum whose swing never quite winds down. But the most startling possibility, these black holes might not be orbiting each other at all. Alternative models suggest we could be seeing a rare illusion. Two independent black holes moving along nearly identical paths, their alignment so precise they mimic a binary system. It's the celestial equivalent of two cars on parallel highways appearing to crawl side by side from a distance, even though they'll never meet. If true, it would mean the Pinwheel Galaxy has pulled off one of the universe's greatest magic tricks, leaving us to wonder how many other cosmic mirages we've mistaken for reality. Regardless of the explanation, this lethargic tango challenges our understanding of how black holes interact. If such a slow dance can exist, what other gravitational oddities might be hiding in plain sight? The Pinwheel Galaxy, it seems, specializes in turning astrophysics into poetry, where even the darkest objects move to rhythms we've yet to fully hear. Deep in the Pinwheel Galaxy's spiral arms, a star pulses with the steady rhythm of a cosmic clock, but this isn't just any Cepheid variable. This one's ticking away time with a secret. It shouldn't exist at all. Cepheids are the universe's yardsticks, their predictable brightness fluctuations helping astronomers measure galactic distances. They're supposed to burn out after a few 100 million years, yet this one gleams defiantly in a region where stellar birth stopped billions of years ago. It's not just old, it's ancient, a relic that somehow outlived its expiration date by eons. One explanation is as violent as it is poetic: stellar cannibalism. Imagine this Cepheid wasn't born alone. Perhaps it had a smaller, aging companion, a star that had exhausted its fuel and begun to swell into a red giant. Over time, the Cepheid's gravity could have ripped material from its neighbor, swallowing layers of hydrogen like a cosmic vampire. That fresh fuel would reignite its core, effectively resetting its clock. It's the astronomical equivalent of stealing someone's youth, a celestial fountain of youth hidden in plain sight. Then there's the measurement problem. Pinpointing a star's age in a crowded galaxy is like trying to guess a single tree's birthday in a dense forest. Some astronomers argue we might be misreading the Cepheid's environment entirely. The ancient region around it could be an illusion, a trick of perspective where younger stars simply appear clustered behind it from our vantage point. Alternatively, the star might have been flung into this older neighborhood by a gravitational slingshot, a wanderer that doesn't belong to the elders it now keeps company with. Yet the most electrifying possibility, our understanding of Cepheids is incomplete. These stars are supposed to follow strict brightness-rhythm relationships, their pulses as reliable as a metronome. But if this outlier is genuinely breaking the rules, it could mean there's an undiscovered class of Cepheids, ones that evolve differently, or tap into unknown energy reserves to extend their lives. It's a reminder that even the universe's most trusted signposts can sometimes point us toward surprises we never saw coming. Whatever the truth, this immortal Cepheid challenges more than just stellar physics. If stars can cheat death so brazenly, what other cosmic rules might be more like gentle suggestions? The Pinwheel Galaxy, it seems, specializes in turning textbooks into question marks, one pulsating mystery at a time. Somewhere in the Pinwheel Galaxy's star-strewn expanse, a celestial beast roars silently, a magnetar so powerful it strains the very laws of physics. This neutron star, no larger than a city, crackles with a magnetic field strong enough to atomize a human from 1,000 kilometers away. We're not talking about ordinary stellar magnetism here. This monster's field clocks in at over 1 quadrillion times stronger than Earth's, a force so intense it warps the quantum vacuum around it, creating a zone where matter behaves in ways textbooks say it shouldn't. What makes this magnetar defy expectations isn't just its brute strength, it's the way its magnetism persists. Normally, fields this ferocious should fizzle out within centuries as the star's turbulent interior settles. Yet here it is, blazing with undiminished fury long after its predicted expiration date. It's like finding a flame that burns underwater, mocking the laws of thermodynamics. Some astrophysicists propose the unthinkable, that inside this star's core, exotic particles might be fusing in ways we've never observed, generating self-sustaining magnetic currents. Picture a cosmic perpetual motion machine where the rules of energy conservation get rewritten in real time. Then there's the starquake theory. Magnetars are notorious for violent crust ruptures, sudden shifts in their solid crystalline surfaces that release seismic waves packing the energy of 1 trillion nuclear bombs. These quakes can temporarily amplify magnetic fields, but the Pinwheel's magnetar seems to be in a constant state of upheaval, its crust fracturing in a relentless feedback loop. Each crack realigns magnetic domains like dominoes falling in perfect sequence, amplifying the field further instead of dissipating it. It's a stellar version of a snowball rolling downhill, growing larger and faster with every revolution, except in this case, the snowball could tear apart the fabric of space itself. But the most radical explanations lurk in the realm of undiscovered physics. Quantum electrodynamics, our best theory for how magnetism operates at extreme scales, predicts an upper limit to magnetic field strength, a point where the field should theoretically collapse into an energy singularity. This magnetar isn't just nudging that limit, it's crashing through it like a bull in a china shop. Some theorists whisper about hyperconductivity, a state where resistance drops to absolute zero, not just for electric currents, but for magnetic flux itself. Others wonder if we're seeing hints of extra-dimensional leakage, where higher dimensions funnel additional energy into our universe's magnetic frameworks. Here's where it gets spine-tingling. If our understanding of magnetism is incomplete, what does that mean for everything else? Magnetars are cosmic laboratories, places where matter is stretched to breaking point. This one's defiance could be the key to unlocking secrets about dark energy, quantum gravity, or forces we haven't even named yet. Every pulse it emits carries encrypted messages about the universe's hidden wiring, and the Pinwheel Galaxy is broadcasting them loud and clear. As for whether this magnetic monster is an anomaly or a herald of new physics, that's the real attraction, because sometimes the universe doesn't just break its own rules, it rewrites them entirely. And this magnetar, it's holding the pen. Floating like a phantom in the Pinwheel Galaxy's halo, there's an enigma that glows with the faintest whisper of gamma rays, a bubble so vast it could swallow our entire solar system 1,000 times over, yet so delicate it's barely detectable. This isn't the aftermath of a supernova or the glare of a pulsar. It's something far stranger, a cosmic soap bubble made of pure energy, drifting silently through space with no obvious engine to power it. Gamma rays, the universe's most energetic light, typically come from violent sources colliding neutron stars, annihilating antimatter, or black holes devouring gas. But this bubble, it's just there, a spectral remnant of something we can't quite see. One theory points to a quasar that's long since gone dark. Picture this: millions of years ago, the Pinwheel's central black hole might have been a frenzied beast, gorging on gas and spewing jets of radiation so powerful they lit up the cosmos. As those jets slammed into intergalactic gas, they could have inflated this titanic bubble, leaving it glowing faintly with residual energy long after the quasar itself flickered out. It's the cosmic equivalent of a light bulb's afterglow, lingering in the dark long after the switch is flipped. The unsettling part: no telescope has found the quasar's corpse. If it existed, it vanished without a trace, leaving only this eerie echo behind. Then there's the dark matter angle. Some particles proposed by theorists like WIMP, or weakly interacting massive particles, could decay into gamma rays when they collide. If a dense clump of dark matter once hovered here, its slow disintegration might have painted this bubble into existence, like invisible ink slowly revealing its message. The challenge: dark matter isn't supposed to cluster tightly enough to produce such a sharp, defined structure. This bubble's edges are too crisp, too deliberate for the usual scatter of dark matter halos. Unless, of course, dark matter behaves in ways we haven't yet imagined, and clumping into unseen galaxies or collapsing into exotic forms that leave gamma-ray graffiti in their wake. Here's where it gets truly bizarre. Gamma rays don't linger. They're either absorbed by gas or streak unimpeded through space. For this bubble to persist, something must be refreshing its glow. Perhaps a hidden particle accelerator, like a neutron star spinning just out of view, or a swarm of antimatter asteroids colliding in slow motion. Or consider this: what if the bubble isn't a structure at all, but a shadow? A region where gamma rays from distant sources are being lensed or focused by warped spacetime, creating the illusion of a glowing shell. It's like mistaking the shimmer of heat haze for a solid object. The most haunting possibility is that we're seeing the aftermath of something far more exotic, a collision between universes in the multiverse, or a defect in spacetime itself decaying like a slowly popping blister. These ideas live on the fringe of physics, but the Pinwheel's gamma-ray bubble dances right on that edge. It refuses to fit neatly into any category, a cosmic Rorschach test revealing just how much we still don't understand about the universe's hidden energies. And that's the real lesson here. Sometimes the most profound mysteries aren't the ones that shout, they're the ones that hover just beyond the edge of perception, whispering clues we're not yet equipped to decipher. The Pinwheel Galaxy's ghostly bubble might be a footnote in the cosmos, or it might be the first line of a story we've only begun to read. At the heart of the Pinwheel Galaxy, something refuses to sit still, a core that changes shape like cosmic putty in an unseen hand. Astronomers first noticed the anomaly when comparing decade-old images to fresh observations. The galaxy's central region, typically a stable hub of swirling gas and starlight, had subtly reconfigured itself. Spiral tendrils of ionized gas that once curled tightly now flared outward. Dense knots of matter vanished only to reappear light years away. These aren't the slow, stately shifts of galactic evolution. They're transformations happening on a human timescale, as if the universe hit fast forward on only this one patch of sky. The most plausible culprit, an unusually erratic active galactic nucleus, or a GN, the supermassive black hole engine that powers the core. Most GNS flicker like candle flames, their brightness waxing and waning as they consume gas. But the Pinwheels appears to be thrashing, its accretion disk warping under gravitational stress like a vinyl record left too close to a heat source. Simulations suggest the black hole might be feasting on a lopsided buffet, perhaps the remains of a shredded star or a misaligned gas cloud spinning its disk into unstable, ever-shifting configurations. Each time fresh matter tumbles inward at the wrong angle, it could trigger cascading disruptions, rearranging the core's structure like a snow globe shaken by a toddler. Yet there's a wrinkle that keeps theorists up at night. Some of the changes defy a GN physics entirely. Filaments of gas have been observed knitting themselves into geometric patterns, perfect hexagons and concentric rings, before dissolving weeks later. Natural processes rarely produce such precise, fleeting symmetry. It's the celestial equivalent of finding crop circles that rearrange themselves overnight, leaving no trace of their architects. This has spurred more speculative explanations. Could these structures be shadows cast by something vast and artificial orbiting the black hole? Imagine a Dyson swarm, a megastructure built to harness a star's energy, but scaled up to galactic proportions, its moving components intermittently blocking and bending the core's light into unnatural shapes. The wild card, time dilation. Near a supermassive black hole, gravity slows time dramatically relative to the outside universe. A construction project that takes centuries near the core could appear to unfold in mere years to distant observers like us. If an intelligence somehow thrived in that extreme environment, what we perceive as sudden shifts might be their deliberate, slow-motion engineering, visible only because the black hole's lens compresses their timeline into ours. Of course, skepticism is warranted. The universe specializes in concocting phenomena that masquerade as artifice. Think pulsars initially mistaken for alien radio beacons. But the pinwheel's metamorphic core forces a humbling admission. Whether the cause is natural or otherwise, our current models can't fully explain a galaxy center that redesigns itself while we watch. And that's the real fascination here. When the cosmos itself starts behaving like a magician's trick, even the most outlandish hypotheses deserve a moment in the spotlight. After all, the line between impossibility and discovery has always been thinner than we think, and the Pinwheel Galaxy seems determined to prove it. Light in the Pinwheel Galaxy is doing something impossible. It's twisting. Not just bending around cosmic objects, but spiraling through space like a corkscrew, carrying a hidden fingerprint of quantum physics that could rewrite the future of communication. Astronomers call this orbital angular momentum light, and its detection here marks the first time such a phenomenon has been observed outside our own cosmic neighborhood. Unlike ordinary light waves that vibrate in flat, two-dimensional planes, these photons swirl through space in three-dimensional helices, each twist encoding information far beyond the binary pulses we rely on today. The implications are staggering. Imagine sending not just a stream of ones and zeros through fiber optics, but entire complex patterns in a single twisted beam, like mailing a library's worth of books inside a single envelope. Current technology maxes out at transmitting data in terabits per second. Twisted light, it could catapult that into petabits, cramming exponentially more information into every photon without clogging bandwidth. The pinwheel's twisted beams are nature's proof of concept, demonstrating that the universe has been using this trick for millions of years while we've only just noticed. But how does light even get twisted? The answer lies in extreme environments. Around the galaxy's supermassive black hole, magnetic fields are so chaotic they act like cosmic blenders, churning light into these spiraling patterns. Plasma jets spinning at relativistic speeds further contort the photons like taffy being pulled in a whirlwind. What's shocking isn't just the existence of these twisted beams, it's their resilience. Despite traveling 25 million light-years through interstellar dust and gravity wells, they've retained their intricate helical structure, proving orbital angular momentum can survive cosmic distances intact. That durability is the holy grail for engineers dreaming of unhackable quantum networks. Here's where it gets revolutionary. Traditional encryption relies on math problems that take centuries to crack, but twisted light offers something better: physics-level security. The quantum properties of these photons mean any attempt to intercept them would irrevocably alter their twist, alerting both sender and receiver to tampering instantly. China's Misha satellite has already demonstrated Earth-to-space quantum key distribution. The pinwheel's light suggests we could scale this to interstellar distances, creating a communication web where eavesdropping is mathematically impossible. Yet the biggest surprise isn't the tech potential, it's the source. Most assumed twisted light would be exclusive to neutron stars or black hole accretion disks. Instead, the pinwheel's beams emanate from relatively quiet regions, nebulas, and even ordinary star clusters. This hints that orbital angular momentum might be as common in the universe as hydrogen. We've just lacked the tools to see it until now. Future telescopes equipped with spiral phase mirrors could reveal entire galaxies pulsing with this twisted code, turning every corner of the cosmos into a potential bandwidth goldmine. The question isn't whether we'll harness this phenomenon, it's how soon. Labs from Tokyo to Boston are already racing to replicate the pinwheel's natural light twisting mechanics using metamaterials and quantum dots. Meanwhile, astronomers are revisiting decades of old data, searching for twisted light hiding in plain sight. Because sometimes the universe's most groundbreaking gifts don't come in flashy supernova or wormholes, but in the quiet, helical dance of photons that have been waiting patiently for us to notice. And in the Pinwheel Galaxy, that dance has just begun. The Pinwheel Galaxy holds a cosmic accounting error, one that's forcing scientists to rethink the very inventory of the universe. In certain regions, normal matter, the protons, neutrons, and electrons that make up everything we can see, simply vanishes without explanation. This isn't dark matter or some exotic substance. It's the familiar building blocks of stars, planets, and even our own bodies, mysteriously absent where theory insists they should be. Astronomers call this the missing baryon problem, and the Pinwheel Galaxy has turned it from a quiet cosmological quirk into a full-blown enigma. Baryons, ordinary matter's scientific name, are supposed to be the universe's ledger keepers. After the Big Bang, they clumped into galaxies, stars, and eventually us. But when researchers tally up all the baryons predicted by cosmic microwave background measurements, nearly half are unaccounted for. The pinwheel's gaps are particularly glaring. Vast swaths of its spiral arms show pockets where baryon density plunges to near zero, as if someone took an eraser to the cosmic chalkboard. These aren't voids or empty regions. They're zones where matter was detected one moment and gone the next, like footsteps disappearing from wet sand. So where do baryons go when they vanish? One leading theory suggests they're hiding in plain sight as ultra-diffuse plasma, strewn between galaxies in filaments so hot and thin they're virtually invisible to most telescopes. Picture a steamy mirror after a shower. The water vapor is there, but you can't grasp it. The pinwheel's own missing baryons might be lurking in similar wisps, ionized to the point where they absorb and emit light at wavelengths we're only now learning to detect. Recent breakthroughs with X-ray observatories have begun spotting faint glows from these structures, like catching the silhouette of a ghost in a fog bank. Yet there's a catch. Even these tenuous filaments can't fully explain the pinwheel's gaps. Some regions are so devoid of baryons that they challenge the laws of conservation. That's led to wilder ideas like baryons leaking into other dimensions through quantum foam, or being siphoned away by cosmic-scale magnetic vortices. One controversial model even proposes that dark energy, the force accelerating the universe's expansion, might be actively converting baryons into something else entirely, a slow-motion alchemy playing out in the galactic shadows. But the most humbling possibility, we might be counting wrong. Our tools for detecting baryons rely on assumptions about how matter interacts with light. If certain baryonic forms like exotic ultra-cold gases or condensed quark matter exist in states we've never observed, they could be camouflaged not by absence but by our own ignorance. It's like searching for a black cat in a dark room, only to realize the cat isn't just hiding. It's a creature we don't yet have eyes to see. The pinwheel's missing baryons aren't just a puzzle. They're a mirror reflecting how much of the universe might be obscured not by distance or darkness, but by the limits of our own imagination. And until we solve it, every galaxy we study carries the same silent question. If we can't find half the stuff we're made of, what else might be slipping through the cracks? Deep in the Pinwheel Galaxy, a dead star refuses to fade quietly into the cosmic night. Years after its explosive demise, its light still reverberates through space like a shout bouncing off canyon walls. An echoing supernova whose delayed reflections are painting a hidden map of the galaxy's secret architecture. This isn't just light traveling in a straight line. It's taking scenic detours, bouncing off interstellar dust clouds so distant that its ghostly afterglow reaches us years after the initial blast. The result, a celestial time machine, allowing us to witness the same supernova over and over from different angles, each echo revealing layers of the pinwheel structure we'd never see otherwise. The mechanics are deceptively simple. When the supernova first erupted, its light raced outward in all directions. Some photons came straight to Earth, while others hit vast dust clouds, some as small as mountains, others spanning light years, and ricocheted toward us at oblique angles. These detours add years to the light's journey, creating eerie repeats of the original explosion. It's like hearing thunder roll in from multiple distances after a lightning strike, except here, the thunder is visible, and each flash carries clues about the obstacles it encountered along the way. But these echoes aren't just pretty cosmic quirks, they're forensic tools. By tracking the timing and angles of each delayed flash, astronomers can triangulate the positions of dust clouds with pinpoint accuracy, building a three-dimensional blueprint of the pinwheel's hidden scaffolding. Imagine shining a flashlight into a foggy room. The way light scatters tells you where the mist is thickest. Similarly, each supernova echo exposes the galaxy's dark, dusty veins, structures usually invisible because they don't emit their own light. Some of these clouds are so sparse they'd make Earth's vacuum chambers seem crowded, yet they're dense enough to bend light like cosmic prisms, the real surprise. Some echoes arrive from regions we thought were empty. One particularly baffling reflection originated from a void where no dust clouds were previously detected, suggesting the pinwheel is threaded with diffuse, fractal-like filaments too fine for our telescopes to spot directly. It's as if the galaxy is wrapped in a spiderweb of dust, and the supernova's light is the only thing delicate enough to reveal its strands. These phantom structures could solve a long-standing mystery, where galaxies stash their missing baryonic matter, the ordinary atoms that seem to vanish when we inventory the cosmos. Here's where it gets poetic. The echoes aren't just mapping space, they're replaying time. One set of reflections shows the supernova's light as it appeared from behind, a perspective we'd never see without the dust cloud's mirroring effect. Another cluster of echoes, still due to arrive in the coming decades, will reveal how the explosion looked from above the galaxy's plane, a god's-eye view of stellar death. It's as if the universe archived multiple camera angles of this event, gifting astronomers with a multi-dimensional reconstruction no telescope could capture alone. Yet the most profound implication isn't about the past, it's about the future. Every newly discovered dust cloud is a potential cradle for future stars, and by charting their distribution, we're essentially reading the pinwheel's recipe for stellar birth. The echoes whisper where and when the next generations of suns might ignite, turning this supernova's death into a roadmap for new life. So the next time you gaze at the night sky, remember, some of the light reaching your eyes might be older than others, delayed by cosmic hurdles you'll never see. And in those delays, the universe hides its most intricate blueprints, written not in ink, but in the afterglow of explosions that refuse to fade. The Pinwheel Galaxy cradles a cosmic contradiction, a red giant star burning brightly where it has no right to exist. These aging stars, swollen and ruddy, typically mark the final act of stellar evolution, yet this one appears significantly younger than its celestial neighbors. Imagine finding a grandparent at a kindergarten birthday party, not just attending but fitting right in. That's the level of paradox we're dealing with here. How does a star skip ahead in the cosmic life cycle? One possibility is stellar theft. Picture a smaller star, rich in hydrogen, locked in a gravitational dance with this red giant. Over eons, the giant's gravity could have siphoned fuel from its companion, funneling fresh hydrogen onto its surface like a vampire stealing youth. This stolen vitality would reignite fusion in the star's outer layers, puffing it into a red giant prematurely, a celestial Benjamin Button trick that defies the usual timeline. Then there's the collision scenario. Two smaller stars, each minding their own business, might have crashed in a cataclysmic merger. The resulting fireball would balloon outward, mimicking a red giant's appearance while hiding its true explosive origin. It's like inflating a balloon by gluing two smaller ones together. The result looks familiar, but the process is anything but ordinary. Yet the most tantalizing explanation flips the script entirely. What if this star isn't prematurely old, but its neighbors are deceptively young? Dense pockets of interstellar gas could have birthed a late-blooming stellar nursery nearby, making ancient stars appear adolescent by comparison. It's the cosmic equivalent of a retirement community built next to a preschool. The contrast warps our perception of age. Here's where the plot thickens. Spectroscopy reveals this red giant's atmosphere is laced with lithium, an element most stars destroy early in their lives. Its presence suggests either the star harbors a hidden reservoir of primordial material, a stellar fountain of youth, or our models of lithium depletion are fundamentally flawed. Either way, this outlier isn't just breaking rules, it's rewriting them. The unsettling truth: if stars can masquerade as elders while secretly being cosmic teenagers, our entire galactic history might need a second look. The Pinwheel Galaxy's paradoxical giant isn't just a curiosity, it's a wrench thrown into the gears of stellar chronology, forcing us to question which chapters of the cosmic story we've misread. And in that uncertainty lies the real discovery. Sometimes the universe's greatest lessons come from its most rebellious anomalies. In the Pinwheel Galaxy's outer reaches, a star flickers with a rhythm that defies all known stellar behavior, dimming erratically, sometimes by mere fractions, other times plunging into near darkness before snapping back to full brightness. This isn't the predictable dip of an orbiting planet or the slow fade of a dying sun. It's as if something vast and unnatural is passing between this star and us, intercepting its light in jagged, uneven chunks. The most electrifying explanation: we might be staring at the shadows of a Dyson swarm, a hypothesized megastructure built by an advanced civilization to harness a star's energy. The concept isn't new. Physicist Freeman Dyson proposed it in the 1960s, but the Pinwheel star offers the most tantalizing real-world candidate yet. A true Dyson swarm wouldn't be a solid shell, as sci-fi often depicts, but a dense constellation of orbiting solar collectors, each absorbing a fraction of the star's light. Their combined movements would create irregular dimming patterns, exactly like the ones observed. Picture a cloud of mirrors circling a bonfire, their reflections flickering unpredictably from a distance. Yet nature has its own tricks. Stellar dust clumps, massive rings of debris from catastrophic planet collisions, could mimic a swarm's signature. These cosmic wreckage fields, filled with uneven chunks of rock and ice, might drift in front of the star at odd intervals, casting shadows that fool our telescopes. There's also the rogue black hole hypothesis, an invisible compact object trailing a disk of gas dense enough to blot out starlight sporadically. Both scenarios are rare, but rarity doesn't equate to impossibility. What tilts the scales toward artificiality is the math. Natural dimming events usually follow statistical patterns, like the bell curve of meteor sizes or the predictable decay of comet trails. This star's light dips, though, cluster in ways that resist conventional modeling. Some astronomers argue the patterns resemble optimized energy harvesting, like a civilization timing its collectors to balance stellar output with storage capacity. The wild card: time. If this is a Dyson swarm, its builders might be long gone. The star's light takes 25 million years to reach us. Any architects could have risen and fallen before Earth's first mammals appeared. Their megastructures might now operate autonomously, humming along as cosmic ruins. Or more chillingly, they might still be there, their existence a silent testament to how advanced life could hide in plain sight. So here we are, left with a cosmic Rorschach test. Is the Pinwheel's flickering star a monument to ingenuity, or just another reminder of nature's capacity to surprise? Either way, its secrets are a mirror. What we see says as much about our hopes and our loneliness as it does about the universe. Among the Pinwheel Galaxy's countless wonders, few are as visually perplexing as the warped dust rings, structures so twisted they seem to defy the very laws of orbital mechanics. These colossal hoops of cosmic debris, which should be perfect circles or smooth ellipses under normal gravitational forces, instead spiral into bizarre corkscrews and jagged figure eights. It's as if an invisible sculptor took the galaxy's raw materials and bent them into abstract art. So what could possibly warp solid rings of dust into such impossible shapes? The prime suspect is a hidden planetary system lurking just out of view. Imagine a young, massive planet larger than Jupiter but shrouded in dusty debris orbiting just beyond these rings. Its gravity wouldn't just tug uniformly, it would create chaotic resonances like a ship's wake disturbing still water. As the planet plows through the dust, its gravitational wake could twist the rings into spirals, while smaller sibling planets might carve secondary ripples, adding layers of complexity. We've seen hints of this in our own solar system. Saturn's F-ring, shepherded by the moons Prometheus and Pandora, displays braids and kinks eerily similar to the pinwheel's warped rings, just on a far smaller scale. But there's a catch. Some of these distortions are too extreme, too precise to be explained by planets alone. That's where gravitational waves enter the picture. These ripples in space-time, first predicted by Einstein, usually form from cataclysmic events like black hole mergers. Yet subtle, persistent waves, perhaps from a distant binary neutron star system, could theoretically propagate through the galaxy, warping dust clouds like a stone's ripples bending blades of underwater grass. If these waves align just right, they might imprint rhythmic distortions onto the rings, turning them into cosmic seismographs recording the galaxy's hidden tremors. Then there's the magnetic wildcard. The pinwheel's interstellar medium crackles with magnetic fields stronger than our Milky Way's, and charged dust grains could be responding to those forces like iron filings near a magnet. Under the right conditions, magnetic turbulence might twist entire dust lanes into pretzel shapes, adding yet another layer of complexity, the most tantalizing possibility. We might be seeing multiple phenomena at once, a planet sculpting the rings while gravitational waves and magnetism fine-tune their edges. It's a reminder that the universe rarely follows single-file explanations. Every kink in these dust rings could be a sentence in a larger story, one we're only beginning to translate. There's a neutron star in the Pinwheel Galaxy that doesn't just pulse, it sings. Most pulsars emit steady, metronomic beats, their radio waves ticking like cosmic clocks. But this one, catalogued as PSR 132, produces a sequence of pulses so melodious, so eerily patterned. They form what mathematicians call a harmonic series, the same mathematical foundation behind musical scales. Imagine a celestial harp strummed by gravity itself, its notes ringing out across the void with a precision that borders on artistry. What could make a dead star croon like this? The answer might lie in starquakes, violent ruptures in the neutron star's crust. These ultra-dense remnants of supernova are encased in crystalline surfaces harder than diamond, yet under unimaginable pressure, they occasionally crack like over-tightened violin strings. Each quake sends seismic waves rippling through the star, modulating its magnetic field and distorting the beams of radiation it emits. Normally, these distortions create chaotic static, but PSR 132's quakes appear unnaturally symmetrical, as if the cracks are propagating in fractal patterns that resonate at specific frequencies. It's the difference between random hammer strikes and a skilled pianist playing arpeggios. One is noise, the other music. Then there's the magnetic symphony hypothesis. Neutron stars are laced with magnetic fields trillions of times stronger than Earth's, and these fields don't just sit idle, they twist, snap, and reconnect in ways that can generate oscillations. Think of it like plucking a rubber band stretched between two fingers, except the band is a loop of magnetic flux spanning the star's surface, and the pluck is a solar flare's energy release. If these magnetic vibrations align just right, they could act like the pipes of a cosmic organ, amplifying certain notes while suppressing others. But here's what truly bends the mind. Some of the notes detected match frequencies predicted by string theory, the controversial idea that all particles are vibrations of microscopic, multidimensional strings. While it's a stretch to call this proof, the coincidence is spine-tingling. Could we be hearing the universe's underlying quantum fabric resonating on a stellar scale? Even skeptics admit the precision is uncanny. These aren't just random tones, but intervals found in everything from Bach concertos to the orbital frequencies of electrons. Then there's the outlier possibility, one whispered in the quieter corners of astrophysics conferences. What if the pulses aren't natural at all? Pulsars have long been proposed as natural lighthouses for interstellar navigation, their predictable beams ideal for calibrating spacecraft. An advanced civilization might subtly modify a neutron star's emissions to encode information, turning it into a galactic-scale broadcast tower. The music could be a side effect or the message itself. After all, mathematics is the universe's only universal language, and harmonics transcend species. Whether born of quakes, magnetism, or something beyond our current physics, PSR 132's song forces us to confront how much we still don't understand about the universe's hidden rhythms. And in that tension between the explainable and the inexplicable lies the real magic, because sometimes the cosmos doesn't just want us to study its wonders. It wants us to listen. High above the Pinwheel Galaxy's spiral disk, an invisible geyser erupts not with water or lava, but with particles moving so fast they shouldn't exist in nature. This is the cosmic ray fountain, a mysterious point in space where ultra-high-energy cosmic rays blast outward with forces surpassing anything human-made accelerators can produce. These aren't just ordinary protons or electrons, they're atomic nuclei packing the punch of a major league fastball into a single particle. If you could see their trails, they'd etch lines of light across the cosmos like celestial lightning bolts, each one 1 billion times more energetic than anything the Large Hadron Collider creates. The source of this particle onslaught has split astronomers into two camps. Team 1 points straight to the galaxy's supermassive black hole, where the chaotic environment could act like a natural particle cannon. Picture this as gas spirals toward the black hole's event horizon. Magnetic fields twist into coils tighter than DNA strands. These coils might snap like rubber bands under tension, flinging charged particles outward at near light speed, a process known as magnetic reconnection. Add shock waves from nearby supernova or colliding stellar winds, and you've got a cosmic pinball machine launching particles to energies that defy belief. Team 2 argues for something even wilder, an undiscovered class of natural particle accelerators. One contender, hypernova remnants, explosions 10 times more violent than standard supernova, where expanding shock fronts could surf particles to extreme velocities like a surfer catching an endless wave. Another dark horse candidate, magnetized filaments of dark matter weaving through the galaxy, their hypothetical interactions creating microscopic acceleration zones hotter than the Big Bang's afterglow. These wouldn't just nudge particles, they'd punch them to energies that make physics textbooks sweat. But here's where it gets really strange. Some of these cosmic rays arrive with a bizarre chemical signature. Lithium and beryllium isotopes so rare they're practically cosmic unicorns. These elements typically form in the hearts of dying stars or neutron star collisions, yet their presence in the fountain's outflow suggests they're being freshly minted in the acceleration process itself. It's like finding a car exhaust that sprays out gold dust. Something about this engine is transmuting matter into forms we've never seen. The stakes, understanding this fountain could rewrite particle physics. If nature builds accelerators more powerful than anything we can engineer, they might hold clues to unifying gravity and quantum mechanics, or even reveal particles beyond the standard model. Every ultra-high-energy cosmic ray is a messenger from the universe's most extreme environments, and the Pinwheel's fountain is flooding us with their encrypted letters. The only question is whether we're fluent enough to read them. At the fringes of the Pinwheel Galaxy, astronomers have stumbled upon a celestial impossibility, a fully formed planet circling a star barely old enough to have left its stellar nursery. This exoplanet, designated PX30, orbits a fiery infant star just 5 million years young, a cosmic toddler by astronomical standards. Here's why that breaks everything we know: planets take time to build. They form from the leftover debris of star birth, dust grains slowly clumping into pebbles, then boulders, then planetary cores over tens of millions of years. Yet PX30 is already a gas giant twice Jupiter's size, looming over its youthful sun like a grown bodyguard attending a kindergarten field trip. So how does a planet outpace its own star's growth? The leading theory is planetary migration, a gravitational sprint where worlds jockey for position early in a system's chaotic youth. Picture this: PX30 might have formed much farther out, where temperatures are cold enough for gas to condense quickly. Then, like a marble rolling downhill, it could have been tugged inward by the protoplanetary disk's dense gas or the gravitational pull of sibling planets. Some models suggest it completed this journey in under 1 million years, a blink in cosmic time. The scars of this migration might still be visible, a gaping hole in the star's dusty disk where the plowing planet cleared its path, or even a trail of disturbed asteroids flung aside like snow from a plow blade. But there's a catch. Migration usually leaves planets in tight, close orbits, yet PX30 lingers surprisingly far from its star, adding another layer to the puzzle. That's where alternative explanations come in. Perhaps we're witnessing a cosmic illusion, a chance alignment where the planet actually belongs to an older, fainter star in the background, its proximity to the young sun just a trick of perspective. Or maybe the star isn't as young as it appears. Stellar age estimates rely on subtle cues like lithium abundance and rotation rates, which can be skewed by magnetic activity or past collisions. Then there's the outlier scenario. What if some planets form differently? Most models assume gas giants need a solid core to kickstart their growth, but PX30 might have skipped that step entirely. In regions of extreme density, gravity could collapse pockets of gas directly into planets, no dusty assembly required, a process called disk instability. It's the difference between building a snowman ball by ball versus watching a snowdrift suddenly slide off a roof as one heavy mass. If true, this would rewrite the playbook for how planetary systems take shape, suggesting gas giants can emerge almost overnight under the right conditions. The implications ripple far beyond one oddball world. If planets can form this fast, then the early universe might have teemed with worlds much sooner after the Big Bang than we ever imagined. Entire civilizations could have risen and fallen in epochs we once considered barren. And if migration can fling giants into stable orbits this quickly, then our own solar system's architecture, with its orderly inner rocks and outer gas giants, might be more the result of luck than inevitability. Ultimately, PX30 is more than just a rule breaker. It's a mirror reflecting how little we truly understand about the cosmic dance of dust and gravity. Every time we think we've charted the path from star birth to planetary maturity, the universe tosses us a curveball, whispering that the story is far stranger than the textbook version. And in the Pinwheel Galaxy, those whispers are starting to sound like a roar. From rogue black holes spewing chaotic jets to vanishing star clusters and twisted spacetime echoing with phantom light, the Pinwheel Galaxy's 30 strangest phenomena don't just defy expectations, they obliterate them. Each mystery we've explored is a crack in the facade of our understanding, revealing how much of the universe still operates in shadows. Consider the diamond planet surviving pulsar winds that should have vaporized it, or the supernova detonating in a cosmic dead zone where no star should exist. These aren't mere quirks, they're cosmic rebellions, forcing us to confront how fragile our models truly are when faced with the universe's boundless creativity. Take the magnetar singing in harmonics that mirror string theory's predictions, or the dark matter hurricane sculpting the galaxy invisibly. Even the seemingly mundane, like the missing baryons or the immortal Cepheid star, hint at forces we've yet to name. And what of the flickering star that could be encased in a Dyson swarm, or the gamma-ray bubble hovering like a ghost? These phenomena don't just push scientific boundaries, they invite us to question whether those boundaries were ever real to begin with. Perhaps the most humbling realization is how often the Pinwheel Galaxy turns impossible into inevitable. The slow dancing black holes, the backward moving gas cloud, the star older than its surroundings, each one whispers that our current physics might be just the first draft of a far grander theory. Could these anomalies be threads leading to unified fields, hidden dimensions, or even the fingerprints of intelligence beyond our comprehension? The beauty lies in not knowing, in the thrilling uncertainty that keeps astronomers and dreamers alike staring at the data, searching for patterns in the chaos. So as we wrap up this journey through the pinwheel's greatest enigmas, remember, every unanswered question is an invitation to stay curious, to challenge assumptions, and to marvel at how much more bizarre and beautiful reality might be than we've dared to imagine. If this galaxy has taught us anything, it's that the universe's strangest stories are often its most profound. Now it's your turn. Which of these 30 mysteries left you staring at the screen, questioning everything? Drop your favorite in the comments, and don't forget to like and subscribe for more deep dives into the cosmos' deepest riddles. The universe isn't done surprising us yet, and neither